In Module 4, we'll move from derivatives to integrals, the second fundamental object in our study of calculus. We began our study with limits, which I promised would be used to define two things, the derivative and the integral. We understood the derivative to somehow be related to the rate of change of an object. The integral can be understood in two different ways. One way is as the inverse of a derivative. The other way is as a way of measuring the accumulation of a function, or somehow the average of a function. We'll develop both of these techniques and link them together in our study of the integral. We'll start with antidifferentiation, in which we'll discuss how to undo the process of taking a derivative. We'll then introduce the object of the definite integral. We'll understand it as the area between a function and the x-axis. This will prove to be apparently difficult to compute, so we'll introduce an approximation known as Riemann sums. We'll then link the idea of antidifferentiation with the integral in what's called the fundamental theorem of calculus. This is really our bridge between the two essential objects of study, derivatives and integrals. In 4.5, we'll extensively discuss basic rules for integration, and these will come essentially from inverting the rules for differentiation. We'll end our study of the theory of integrals with what are called U substitutions, which is a more sophisticated method for computing integrals. Other topics that one might be interested in covering in later courses in calculus include other techniques for performing integration, including integration by parts and more specialized substitution techniques. But we'll focus on U substitutions, which are the most fundamental.